and welcome to this interview for the SDG Collection at Frontiers for Young Minds. My name is Isla, and today we will interview the authors of the research paper for SDG 10. Would you like to introduce yourselves?
Sure. Hi, Isla. Well, my name is Montserrat. I am from Mexico, and I am a PhD student at the Sensors Lab at KAUST. I work on wearable sensors and smart materials and a little bit of deep learning architectures.
Hi Ayla, my name is Khalid Salama. I'm a professor of electrical and computer engineering at the SIMS division at KAUST, and I head the Sensors Lab.
If your news article was a headline, what would it be?
I would like to highlight a little bit the punch of our research. So I will say something like tech meets humanity or something like that, like the smart device that translates mouth movements into a voice or something like that.
Yeah.
I would call it assistive technologies for social justice. So basically the article is about how to develop technologies to help with social causes, and this is one of the technologies that can help with that.
Cool. Tell us a little more about your research at KAUST. Why did you decide to work on this topic?
Okay, so the magnetic skin was developed actually in our lab, like in 2019, by actually my mentor that is now a professor, Abdullah Mansouri, and he developed this material and he started working with different applications. He always focused on humanitarian purposes. So for example, he used it first for people with quadriplegia to help them move the chair or interact like independently by detecting the changes of these magnetic patches. So when we were looking into more applications for this, we thought, what if we could, for example, detect the movement of the lips for people that cannot produce voice? And that's basically how it started.
And you?
In my lab, we work on wearable technologies. We are trying to develop different technologies that will improve the quality of life for people. And this is one of the technologies that came up with about 5-6 years ago, and we're trying always to look for new applications to deploy it in the field.
How does the magnetic skin compare to other speech-assistive technologies like text-to-speech devices or sign language apps?
Well, first I want to highlight that from the voice disorders that exist, most of the devices that exist nowadays are focused on people that are mute or deaf. But we are forgetting all the other groups of people that are vulnerable because of a voice disorder. So current technologies do not work for them because they had the ability to already move the mouth, but for some reason, they lost the ability to produce sound itself. So these technologies do not work for them because the need is different. So that's the first difference with our technology. And the second one is, for example, that most of the devices are not wearables. Since most of them rely on either a camera, this requires like a setup that might need more power or computational power, and there could be a misinterpretation sometimes of the signs. There are more than 300 sign languages, so there's no universal one. So it's hard to shift this language to just one. And yeah, most of them rely on something more powerful as a computer to work, which is not a very, that is not a tool that could be used in their daily life.
Okay, so my next question is, how would this device work in a casual conversation with two people? And what about a group discussion?
Okay, first we need to remember that we have patches that are super close to the lips, and also the sensors are close to here. So when we design it, we focus that the device will only detect these patches and not the air magnetic field or other magnetic fields that could come from nearby devices or other things. So this is the first point. We make sure that the detection will be only from the person. In that way, we can have a conversation and your voice or your phone or something will not interfere with my device. Yeah.
And we envision that you will have either a screen where the text that you're trying to produce will be shown on it so that you could have a conversation between two people, or you could have a speech synthesizer which actually can produce the same text that you're trying to produce.
What were some of the challenges you faced with this technology?
Well, the first one is that since we live in a planet where there are magnetic fields, we need to erase those noises in our signal. So that was one. And also to have the sensitivity from our sensor to read the magnetic field from our device, like from our patches. So we need to make sure that this signal was strong enough for our sensor to be detected. That is regarding like at the device level. And the other one was at how to collect the data. Since this is a new technology, there is no data available that we could just download from internet and try it. So we needed to ask a lot of volunteers in order for us to have data and collect it for our device to work.
Okay. How do you see this technology impacting people with disabilities, and how do you think the technology will evolve?
Well, this will help a lot of people, even though they are a minority in the voice disorder spectrum. They are still there, and they need someone to fight for them. So I think this is what we are doing somehow, and I think this will evolve into be more like the size of the device could be reduced, so it's more appealing for the person to wear it, and it could be like customizable, maybe different colors, or to make it more appealing. Yeah.
How affordable is it? How can it be made available to people in developing countries?
Well, for example, our headset was 3D printed, which that reduces the cost a lot. But if, for example, we start producing more, or if we see or envision this as a product, mass production is way cheaper, and we could do a partnership with someone that could afford to produce in a cheaper way.
Hello, I'm Aisha. So my first question is, what do you see as like the further improvement you can make to this technology?
So there are many areas that we can work on to improve the technology. Among them is how to make sure that these patches that we put on your skin are not going to be irritating your skin. Ideally, you want to have them sitting on your face for a full day, and that causes some skin irritation. Second one is how to make sure that they are sticking there and they are not moving around. So that's another problem, which is how to make sure that they stay there and they are not going to move around. So that's the second thing. And of course, one big issue that we are working on is how to make it affordable. We don't want something that is extremely expensive that people can, with means, will be the only ones who can afford to use it.
Okay, so my next question is, does your research connect with any other UN SDGs?
Well, yeah, as we know, the SDG 10 is to reduce the inequalities. And with this, we not only mean at the social or economical impact, but this is like it transcends into just discrimination or how you connect with the world, which is, of course, a big deal. So the United Nations have like different purposes or focus on different things, but I think that with this, they correlate a lot with different SDGs, and you can read it in the article. It's there.
Yeah. Okay. So my last question is, what is the most important thing that you want us to learn from this article?
From my point of view, is that most of the time we only hear the most popular disease or the one that collects, I don't know, more funding. But we sometimes forget that there are other diseases there, and they are also important. And science can provide a way for these diseases or people to have a voice, and that's what we're trying to do. So, yeah.
And another thing that I'd like to highlight is that this technology we developed about 6-7 years ago, and at the time we thought that we did all what we can do with this technology. However, with new people, new students, new ideas, we can actually find out that we can use the same technology in a completely different application that's very valuable. So I ask people always, you have to look around and see how can you recycle some of the technologies that are outdated in new application to solve a problem that people are worried about.